Alright, here are our solutions for the first quiz for Math 251. Essentially, I'm throwing a ball up in the air, and its position is given by this function, and you want to figure out its speed. So to figure out the average speed, or average velocity, we want to find the slope of the secant line. And if you're asked to find the slope of the secant line, you better be given 2 points, because we need 2 different points to define a secant line. Unfortunately, we are. The first of those points has an x-coordinate of 1, for this t equals 1 here. And the second of those points has an x-coordinate not of 2, but of 2 more than 1, in other words 3. And to figure out the corresponding y-coordinates, all we got to do is take those 2 x-coordinates and plug them into this function up here. So if I change all the t's into 1s, I get negative 2 plus 12 plus 6, which is what, 16? And if I change all the t's into 3s, I get 9 times negative 2 is negative 18, plus 36 is positive 18, plus 6 is 24. So really, all I'm asked in this first problem is find the slope of the line that passes through these 2 points. And you can do that. The slope formula tells you it's the difference in the y-coordinates, so 24 minus 16, divided by the difference in the x-coordinates, 3 minus 1. So in other words, I get that my slope is just equal to 4. So the average velocity is 4. I don't care about units, so we'll just call it 4, call that good, and move on. Part B says estimate the instantaneous velocity of the ball. So not the average velocity of the ball, but instead the instantaneous velocity of the ball. To do that, we need to know the slope of the tangent line. We will learn in this class how to calculate the slope of the tangent line. But right now we don't know how to calculate the slope of the tangent line, so we're going to estimate the slope of the tangent line with secant lines. So for my first secant line, maybe I'll use the point 1, 16. And for my second point, instead of choosing 3, since that's so far away from 1, I'll choose a value closer to 1, like maybe 1.01. And I can't do that math in my head. I can't figure out what negative 2 times 1.01 squared plus 12 times 1.01 plus 6 is. But that's what calculators are for. My calculator tells me that this is 16.0798. And with these 2 points, I can calculate the slope of that secant line. I can say the slope is the difference in the 2 y-coordinates, so this number minus this number, which leaves me with 0.0798, divided by the difference in the 2 x-coordinates, so this number minus this number will give me 0.01. You can evaluate this. You can divide by 0.01, multiply the top and the bottom by 100, move the decimal place twice, you get 7.98. So the slope of this secant line is 7.98. I want to estimate the slope of the tangent line. I don't know, this is pretty close to 8. Maybe that's my answer. It is my answer. Supposing you didn't know that, you could create a second secant line. We could again use 1 and 16, but now instead of taking 1.01, that is some point that's just slightly greater than 1, let's take some point that's slightly less than 1, like 0.99. And let's do this same calculation, except instead of 1.01, I'll do 0.99 and figure out what the y value corresponding with that x value is. And my calculator informs me that that y value is 15.9198. So I can calculate the slope as the difference in these 2 values. 16 minus this number is 0.0812, 0.0802. And this number minus this number is 0.01. And if I divide the 2 of those, I get 8.02. So one secant line told me that the slope of one secant line was 7.98. The slope of my other secant line was 8.02. So I am going to guess that this is 8. That might be a little unsatisfying to be guessing, But I don't know, it's a whole number between 7.98 and 8.02. Or it's a number between those. I guess you don't know that it's a whole number, but it is. I think that's a pretty good estimate. Turns out that's the exact answer, although we don't know that at this point in the class. Number 2 is actually quite similar to number 1. First part says calculate the slope of the secant line. One of the points on the secant line is 2, 4, and the other point we're given an x-coordinate of 2.01. So we can figure out the y-coordinate. We could say we got one point at 2, 4, and my other point at 2.01. And whatever would come out of this function if I put 2.01 into it, in other words, 8 divided by 2.01. And that's equal to that number. Sure, 3.9801. Close. So I can figure out the slope. You know, I don't like using decimals. I'm not going to do that. I'm going to leave this as a fraction. I'm going to say that the y-coordinate is 8 divided by 2.01. And so to figure out the slope, I'm going to say the slope is the difference in the two y-coordinates. So 8 divided by 2.01 minus 4 divided by the difference in the two x-coordinates, which is 2.01 and 2. And the denominator here is just 0.01. For the numerator, I need to get a common denominator to put these all together. So I could say it's 8 minus 8.04 divided by 2.01. Okay, where did that come from? 4 is the same as 4 divided by 1. If I multiply the top and the bottom by 2.01, I get 8.04. So now I have this fraction here. 8 minus 8.04 is negative 0.04. And I'm dividing that by 2.01. And then I'm dividing that whole thing by 0.01 over 1. The way you divide fractions is like multiplying fractions, but you multiply by the reciprocal of the denominator. And so if I multiply straight across here, what I end up with is negative 4 divided by 2.01. And negative 4 divided by 2.01 is roughly equal to 1.99, negative 1.99. Slope of this secant line is this value. Estimate the slope of the tangent line. I'm going to guess that it is negative 2. Why? Because that's close to negative 1.99. And if you know the slope of the tangent line and you know one point on the tangent line, 2, 4, I can come up with the equation of the tangent line. So this is just the line with slope negative 2 passing through the point 2, 4. One way you can do this is you can use the point slope form of a line, which is y minus y1 equals m times x minus x1, where m is the slope, negative 2 in this case, and x1 and y1 are 2 and 4 respectively. So if I solve this equation to get it into slope-intercept form, I got y minus 4 equals negative 2x plus 4. Add 4 to both sides of the equation, you get y equals negative 2x plus 8. Negative 2x plus 8 is the equation of the tangent line to the curve at this point. And I guess that is the end of this quiz.